Yeah, now we discussed about IDs and why we need IDs. Okay, as we know, like we'll be using any IDs. Okay, like why we are using IDs. Okay, it's just giving a better environment. It can be online or okay. So maybe you can download any IDs and all. You must have done it like lot, right? And you'll be writing the program and you can compile the program and you can see the output in the console. I think that we discussed already. It can be any Visual Studio Code or any IDs if you want, you can use it. But for embedded system, embedded C programming, so there are dedicated IDs to depend even the controller. You can use Keel ID or MP Lab, and even we can use Cube ID. So, like maybe in this program, I will prefer to use Cube ID, which is open source. We can use that with any like any system, Linux or Windows, whatever it is. All right, so that's what I want to tell you about ID. And using this ID, you understood that you'll be writing some software. That also I agreed. Okay, so this is how maybe you started programming, right? Maybe you written the first program just to add two numbers. So you're asking the user to enter the first number, enter the second number. So in the program, you must have done that sum equal to a plus b, if a and b are the variables, and you will be printing the result in the console. That's it. Everything was happening in the system, in that IDs itself. That means everything was happening for the host machine. Host machine means like our laptop or desktop, whatever it is, where we are writing the program, there only we are compiling and we are observing the output there itself. Okay, so that's what we already experienced. But right now, what you are going to do, you will be writing some program like in the host machine only. You'll be writing the program in your laptop, okay, with the help of that ID. And finally, that ID, I'll tell you like what are the different stages for it. But finally, what that ID will be doing, that ID will be converting this program to hex file. Okay, hex file. Uh, dot hex file. So what is this dot hex file? It will be the compressed version of the whatever high level program, means whatever high level language you used, can be C, C++ or whatever it is. So you return the program using this high level language. Why we are using high level language? Because we are comfortable with that, right? You can't write machine code instruction, of course. Machine code means it will be the combination of zeros and ones. And there are other possibilities that you can use assembly language. That will be some mnemonics. Maybe I'm not sure. Somebody already done that like in their college days. Okay, for microprocessor programming, especially if you remember, we used to write this instruction move a comma b or something, add for addition, sub for sub. So this kind of mnemonics we were using, and we used to write some program. That is assembly language instruction. I'll show that anyway, like this course, I'll be showing that. Not mandatory to know all this, but anyway, at least you should be like aware about the high level language. High level language means like you are learning, everybody like learning at least a programming language, and I'll prefer that you are learning C program and you are coming for embedded C course. Okay, so you return this high level language, and this high level language instruction the machine can't understand. Okay, so what you will be doing, you will be converting that to machine code and will compress it and will create a dot hex file. Okay, and this dot hex file where I will be storing. If I am storing this dot hex file inside my computer, inside my laptop, okay, how this AC remote will be working? All the time I can't connect this AC remote with my system, right? Maybe lakhs of products are happening. That means once you tested one prototype, okay, you created a product, okay, you tested all features, everything. So that testing phase, we were using our host machine, okay. So once that done, then we are starting the production. So once we are doing the production, we have to cover or we have to transfer this code, whatever the software we written, that we have to transfer to the target board, target machine, or target product. Are you getting? So the target board is the embedded device. So embedded device is something which is unique. Unique in the sense that product is unique, right? For example, if I written the software for AC remote, I can use that software only with the AC remote. So once I written the software here in my desktop, I'll be converting that to hex code and I will be dumping this hex code to the target machine, which is my AC remote as of now. Okay, so maybe if I am making a robot, it can be different software. I can't use the same software inside the robot, right? Robot will be having so many advanced features. It will be working with so many motors, actuators, or sensors, and all. So the software will be different. And yeah, of course, that software also I'll be writing using the a host machine, and finally I'll be converting that to Xcode. Then I am going to implement or I am going to dump this to the like the target machine or the target board. Target is like the microcontroller. So I hope now you got a clarity what is microcontroller. Microcontroller can be same even for AC remote and a small robot. Okay, no, I'm not telling for the advanced robot I can use the same microcontroller which fit for the AC remote. Okay, So the microcontroller can be same also, but depend on the software, depend on what kind of software we written, it will function differently. I think it's all clear, right? It's common sense. Okay, what kind of instructions I am giving, accordingly they will function differently. Okay, so that is fine. So this kind of software is important in embedded system. Okay, so I told already, as of now I'm just repeating, it's a combination of hardware and software, and the software we will be writing for the host machine, that means for the desktop. We'll be doing all the testing, everything, even using simulator we can test it. Okay, once everything is done, then we'll be implementing, or we'll be dumping this code to the microcontroller. So you understood what's a microcontroller and what's a microprocessor. At least just think about microcontroller means which is we are using inside the AC remote. Okay, microprocessor is something which we are using in the desktop or laptop, whatever it is. The bigger processor. As of now, just understand like that. Maybe later on, I'll be categorizing, I'll be showing the differences between microprocessor and microcontroller. Okay, I think that's clear. And embedded system, I think that is also clear. What is embedded system? It's a combination that you understood, that is fine. And it is actually designed for a special purpose. I told already the hardware or the software which I am making, if I am choosing for an embedded device or embedded system, for example, where like our washing machine, that's an embedded system example. I am having certain buttons, like one display is there. Okay, so that means not that display, that buttons actually controlling the like the rpm, okay, rpm of that motor, or maybe the water level or the heater level, everything is getting controlled as per that button. Okay, whatever buttons we are pressing. Okay, I think right now most of the machines are touchpad, maybe iot based washing machines, I think maybe soon it will be there in the market, or even artificial intelligence machine. I'm not sure about it, whether it's done already. Yeah, of course, possible, right? Even the cloth, the depend on the type of cloth we are putting to the machine. The machine itself should understand what type of cloth it is. It's woolen or maybe it's cotton. Then accordingly, that machine itself should take the decision. What should be the washing time? What should be the water temperature? How much? Like how much detergent they need. Okay, so the machine will be able to take this decision, and accordingly they will do the washing process. But anyway, you understood that once I created an embedded system, I will be always making a special purpose. It's a unique purpose. If I done that, I can use the product only for that use. Okay. But on the other hand, microprocessor is not that. That is general. We can modify according to like our use. Okay. So for embedded system, like we'll be having the processing, memory, and peripherals. We'll be coming to that. I think processing is clear. What's a processor? That means the microcontroller only we are talking. Okay. So inside even the microcontroller, there is a processor unit. So that's the reason it's written processing here. And the memory, of course, we need memory. Okay, what is temporary memory? Temporary memory or permanent memory will be coming to that. RAM and ROM, basically. Okay. And apart from that, we will be having peripherals, because embedded system, you understood that it can't only work with the microcontroller. Microcontroller, of course, will be there, but you will be connecting so many input and output devices with the microcontroller. Basically, like embedded system in simple way. I'm not talking about the advanced system. In simple way, it will be a controller. Like you can imagine like the human body. Okay, so maybe like our brain is a microcontroller, and we have so many sensors like our eyes, nose, ears. Okay, so this all are the different sensors, and we have some output devices like legs. Okay, or maybe hand or maybe mouth. Okay, we are speaking, right? So this all will be the output devices, and depend on the instruction from the sensors. For example, if I'm seeing something, if I have seen fire, okay, what I will do? So this signal is maybe sending from my, like from my eye to brain. Okay, so brain will quickly process that, and it will take the decision. I have to quickly like go out of this room, right? Something, so maybe for that I'll be like, I don't know whether I'll speak something. Okay, sometime we'll be screaming. Okay, so we'll be using this mouth as an output device, or we'll be running using our like legs. Okay, so this is, it can be a combination of input and output devices, but the microcontroller, like our brain, will be controlling all these actions. I think it's clear, right? Yeah, now I'll just show you. These are so many applications of embedded system, like we discussed in mobile phones, automotive industry, especially like now automotive industry is like skyrocketing in using this embedded system, right? The old car. Okay, so what all features they were having, and what are the advanced features we are having. Okay, everybody using so many advanced things, right? The GPS is not, of course, advanced, and we are using so many sensors and lots many monitoring system, security system. So all this are controlled by embedded system. Maybe you have seen, right? When you have seen the first time the airbag, you must have seen that. Okay, how good it is. Okay, how helpful it is, right? It was not there in the earlier like earlier cars and all. Like it was not there in any like earlier vehicles and all. So right now we are having all these features, and how it is getting controlled, and when this airbag is popping out. Okay, so some sensors will be sensing some like a dangerous situation, like accordingly immediately the airbag is popping out. And maybe we have like so many sensors which is constantly monitoring the like the car temperature or something. If it is abruptly going high, the temperature is going high, it can take some sudden action. At least it can apply the brake suddenly. Something can happen. Some sensors will be sensing, and accordingly, some different actions can happen. That actions and all maybe users, or maybe not users, as actually the manufacturers or maybe the software developers, they are deciding. Okay. So as an embedded engineer, our task is just not only focusing on the software part. You have to use the common sense, right? What I mean by the common sense, like in certain situation, how you want to take the decision. So this decision making is an important skill for an embedded engineer. They have to take, means they have to think in real life situation. If this is a problem, then how I will be reacting. Maybe they have to take a survey. So they have to inquire with multiple people, and you have to come up with a better solution. This is also important. It's not only like you understood the hardware and software, then you can become a better embedded engineer. Not possible. Okay. So like everywhere, like maybe in different industry, we are using like embedded system. Okay, now I would like to explain about what is embedded system structure. Okay, embedded system structure, as we discussed already, it will be a hardware and software combination. Okay, so in the hardware, we discussed already the processor or the microcontroller, and we'll be having certain memory devices, RAM, ROM, we'll discuss about it. Okay, and we will be having certain I/O devices, input output devices. What is input output devices? I told already, input devices mean the sensors and all, or push buttons. These are some simple input devices where you are sensing something from the environment. You are sensing some information. Okay, so these are the input devices. Output devices means I told the example of motors or even the LEDs. Okay, so all will be the output devices, or it can be a microphone. Okay, so anything. So that will be the output devices, or it will be a combination. So this is about the hardware part of embedded system, and the software part of embedded system. Like if you have seen, you must have seen like device drivers, which is directly connected to the like hardware. Okay, device drivers is must. Like you will be like developing, you will be writing the device driver code for each and every peripheral devices. Okay, and on top of that, you will be having operating system, then application software. It's not mandatory for all devices and all. For example, for the AC remote, we don't need operating system. Okay, we'll be using device driver. That's it. Operating system is not mandatory. Even application software is not mandatory. For example, if you're creating a robotic project. Okay, so as I told you, or maybe a big humanoid robot you are making, so many sensors it is having, like it can speak, whatever it is. So in that cases and all, you will be having some application software to interact with that robot, right? So you'll be having a display, so maybe it can be a touch screen, whatever it is. So you'll be pressing some buttons, you can ask the robot some questions, so many things can be done. So there you will be having an application software. Okay, so application software can be directly like implemented on that. So this Android, that means they become high level. He'll be having multiple application software to interact with the robot. So just to manage all these things, like if you want to connect the hardware and software, of course, there should be a connection between hardware and software, right? If I'm using this GUI, okay, graphical user interface, or if I'm using this application, like in this application, if I'm clicking here, the robot should speak something. Okay, so you understood that there should be a proper connection between the hardware and software. If any resources are required, you have to like get into that. Okay, resources in the sense you have to use the microphone. Okay, microphone of the robot if you want to speak, or maybe sometime if you want to select the language. Okay, so multiple interaction should be there, and there should be a combination between the hardware and software, and you will be having multiple application software like this. So that time and all operating system is required. I think all are clear about this operating system. I don't want to teach everything, right? Operating system, we are using Windows. Okay, it can't be Windows or Linux, of course. The operating system will be developing for this particular embedded application itself. Okay, it can't be very heavy like Linux or Windows. It can be a application, sorry, it can be an operating system which is specially designed for that embedded device. It's clear, right? I told already it's not mandatory for all embedded devices. Sometime we'll be only using device drivers, or sometime we'll be using the combination of all this. Okay. So that's what about the software part of the embedded system. I think now it's clear. Okay. Just imagine about the different different application. Just imagine about different products, okay, of embedded system. Then you will be able to connect all this information what I'm telling. I think even in washing machine, the software operating system and all not required, right? If it is required, if it is very advanced, then of course you can go ahead with it. Okay, or else only the hardware and the device drivers. That's enough. Yeah, so here I already showed you the diagram. So in the lower layer we have seen the hardware. Okay, it can be the processor, memory devices, and I/O devices, and on the upper layer it will be the software. Software will be consist of device drivers. You will be able to, you will come across this term a lot. What is device driver? So it's better to know what is device drivers. Yeah, so let's see what is device drivers. You will be like you are coming across this term a lot. What is device drivers? Which will be a software written directly control the embedded hardware and provide an API. Okay, API interface to the upper software layers. Device drivers abstract hardware details from the application programmer. So it means to say device driver who will be developing the device driver, they should know about the hardware detail. Okay, so they should be very clear about what controller they are using, what are the features of that controller. Then accordingly they can write the program. They should be very clear about the hardware. But on the other hand, maybe like it's not necessary that everybody should learn or everybody should be aware about the hardware detail, right? So somebody writing some application program like any GUI, okay, so they are creating an application. I told the example, if I'm clicking this button this should happen, if I'm clicking this should happen. Okay, so if this kind of program application software, if anybody is developing, they don't want to know about the whole hardware detail, not mandatory. Not even necessary to learn all this. They can focus on their like their task. They can make that application more interactive, more beautiful, more graphics, whatever they like they can add it. But all this will be connected to the device drivers. The device drivers actually will be controlling the actual hardware. Okay, if I am pressing this button, the LED should blink. Okay, so whatever these features are required, so they should be very clear about the hardware details. That's it. And operating system, as you know, that will be managing all the resources whatever we are using here. Okay, and application software is a software that perform the main functions. Okay, main functions what it is designed for. So this diagram giving you more insight about embedded system structure, what is an embedded device and how it is working. So you'll be able to see the host machine and the target machine separately. Host machine, the machine where we are writing the code. Maybe it's our desktop or laptop, whatever it is. And just to write this code, we'll be using so many software tools. I'll come to that, what are the different tools we are going to use. And finally, once it's done, once it's tested, we'll be dumping that code to the microcontroller. The microcontroller, of course, will be on a PCB. It will be mounted on a PCB, printer circuit board. Okay, maybe you have seen that, right? Green color or red color, what are the different colors, even blue. Okay, so it can be anything. So many components will be mounted on that. So there will be an important component that's called microcontroller. So we'll be dumping this code once we tested everything. I already told we will be converting that to Xcode and we'll be dumping that to the microcontroller, okay, which already embedded in the PCB. For that, we'll be getting the help of programmer, debugger. Okay, so all this. And here you can see inside the processor will be having an internal memory. So in that internal memory, we'll be storing this program data. Program. Okay, if any data are required, so that will be storing in the data memory. Program will be storing in the program memory. Okay. A program memory, of course, it will be read-only because we don't want others to alter the program, whatever we dump through that microcontroller. And embedded system, of course, will be having a power unit. The power unit, sometimes this embedded devices will be working with the like AC power, okay, with the help of adapter. This devices directly will be powered, okay. So most of the time you will be able to see that the embedded device means once you created a device, it should work whenever it's getting the power. So that should be the idea. Okay, once I switched on the device, it should be functioning till I am switching off it. Okay, so maybe that is one way. Okay, so that is one way to power up, or else you will be most of the time we'll be using batteries and all. Even for AC remote, we know we are using battery. And maybe like in medical equipments like pacemakers. Okay, so there and all we have only the option to use battery, right? So in that cases and all you have to be very like careful if you are creating this kind of devices which we are implanting in our human body. So we have to be very careful about the power consumption. Okay, every time we can't take that device and we can't change the battery, right? So that should be consuming low power. Okay, so that we have to like ensure. And apart from that, in PCB, we'll be using the external hardware, as I told already, the sensors, actuators, motors, and all. So that we'll be using. Now we are coming to this conclusion. What is the difference between a simple C program, which you already done, most of you, 90% of the participants or maybe 90% of the students are learning C program as their first programming language in school. Okay, but I started with C++ somehow. All right. Yeah, so that is about C program language, which you are already aware, and we are comparing that how it can be different, like how it can be different. Why the C programming is entirely different from embedded C? It can't be entirely different. It can be only the applications will be different. That's it. Yeah, so now let's start about C program. So C program, as we know, it's a general purpose programming language that allow a structured programming. There is no oops concept in C, right? I think all are clear what is oops concept. You must have done C++, why C++ you want to learn. Maybe you have done the concepts like class, okay, and a lot of other feature like polymorphism, abstractions and all. Okay, yeah, so that was there in the C++, but C is a language where you're writing structured program. Why I'm telling structured program or maybe a procedure oriented programming, that is C programming. Okay, why it's so? Because there we know everything is happening step by step. So many functions will be there. Okay, so maybe in the main function we'll start the program. So the control is actually going line by line, one by one. If any functions are coming, maybe accordingly the control, the program control we are changing. Okay, that's it. But rest of the time, it's like a procedure-oriented programming language. That is C. It's a general purpose programming language. But on the other hand, embedded C will be a set of language extension for C. C, it's an extension of C language only, which is designed to address common issues. Yeah, on the other hand, embedded C, we know it is extension of C program. That means most of the syntax, semantics, everything is similar to C program. But we know that C program, embedded C means it's a simple C program that we are using for a particular hardware, particular target machine. Okay, so that's the difference, right? Yeah, so we will be like adding a little bit of hardware details even in the high level program language like C. So hardware terms will be adding in the C program. So that become embedded C. And yeah, C program developed by Dennis Ritchie, like in AT&T Bell Laboratories. Okay, I think maybe in 1970s. Okay, it's very old programming language. And here, like in embedded C that developed by the C standard committee, they have done so many changes and so many features they added to that. And C program, of course, it is hardware independent. If I written one program for my this PC, it's a Lenovo PC, whatever it is. So if I am writing this particular program for this PC, this particular compiler I am using, this particular IDE I am using, the same output I am going to get if I am testing this with any other PC.